Hi everyone. In this video, we will discuss about the IMACS framework. So IMACS stands for Image in the Closed Loop System, and we consider a case study of lane keeping as a system to explain it a bit further. So let's consider a system or a plant, and for a lane keeping as a system, it's a car. There is a camera attached in front of the car, let's say somewhere here. And the camera senses the road ahead, and there is a sensing and processing task which does image signal processing and perception. So let's say the idea is that from the image captured by the camera, the task identifies the lanes and also computes the lateral deviation of the car from the center of the lane. So this lateral deviation information, or let's say the state, is fed to the controller, and then the controller computes the steering angle, which should be actuated so that the car stays on this, or the car goes to the center of the lane. So one big challenge is how do you validate such kind of systems? So, in case if you don't have a car, you still want to test the controller first, and you want to test its functionality, its timing, its temporal properties, and so on. So what the IMACS does is it helps to verify and validate such kind of systems in a digital twin environment. So we have a simulation engine which simulates the physics, environment, sensors, and the actuators. And you can do your design time analysis and design, and you can interact with the simulation engine during your design time by a model in the loop or software in the loop simulations. And you could also do a runtime verification and validation by writing your codes in for instance, in a platform like NVIDIA, and doing a process in the loop or hardware in the loop simulations. So currently IMACS is open sourced for both VREP and VBOT's simulation engines. And yeah, we basically do our controller design using MATLAB, and you do the timing analysis using STF32. So in a nutshell, what can we do with IMACS? So we can actually validate for functional properties. We can measure temporal properties. We can measure energy numbers. We can do a controller design. We can do a software in the loop debugging. We can do hardware in the loop debugging, and so on. So if you want more information, you can go to this website. So in the IMACS virtual machine, we implement, let's say for an example, an image processing task, which involves image signal processing and perception stage. So what this basically does is the ISP stage takes in the raw image from the camera. It goes through a series of steps like demosaicing, denoising, color mapping and white balancing, gamut mapping, tone mapping, and then you do a compression of the image. And this compressed image is then fed to a perception stage, which also goes through a series of steps so as to obtain your lateral deviation for the car. So in the perception, you do a region of interest selection. You basically crop the image only to capture the feature here, which is the lane. You do a perspective transform. You do a static image thresholding, and you do a sliding window-based lane tracking to find the lanes. And then you calculate the lateral deviation from it. So these are the steps in the image processing part. And then you do a controller implementation. So the basic idea for control design is that you do your design in MATLAB, and then you generate the relevant controller matrices, for instance, your gain matrix K, or your phi augmented matrix or gamma augmented matrices. And then you store these matrices in memory for runtime implementation. and then the or then your files, let's say at your .cpp files will access this matrices during runtime implementation. So the main idea, or let's say the main point we have to worry about, is the timing. So the controllers so the system is a discrete system. So you design controller assuming let's say a period h and a delay tau. So it's necessary that during the implementation, this h and tau are guaranteed. So if they are not guaranteed, then I mean there is no proof for stability. So what we do in the Emacs is we follow a synchronous simulation, and in which we are able to enforce this tau and h, and you can enforce this behavior in the framework. So this is the Emacs framework in a nutshell. And if you have more queries, or if you need more information, just go to the website.